Hi everyone, I'm Jung Chin, a PhD student from Xi'an Jiaotong University. In this video, we will introduce our work, generaltrack, towards generalizable multi-object tracking. I will give a short introduction to this paper below. Existing trackers struggle to accommodate all aspects or necessitate hypothesis and experimentation to customize the association information, motion, and/or appearance for a given scenario, leading to narrowly tailored solutions with limited generalizability. In this paper, we investigate the factors that influence trackers' generalization to different scenarios and concretize them into a set of tracking scenario attributes to guide the design of more generalizable trackers. Furthermore, we propose a point-wise to instance-wise relation framework for MOT, which can generalize across diverse scenarios while eliminating the need to balance motion and appearance. Multi-object tracking aims to locate targets and recognize their identities from a streaming video. It is an essential task for many applications, such as autonomous driving, robotics, and visual surveillance. Despite great progress in the past few years, the MOT task remains challenging when the trackers are generalized to diverse application scenarios. Multi-object tracking encompasses various tracking scenarios, each characterized by unique traits. Effective trackers should demonstrate a high degree of generalizability across diverse scenarios. In this paper, we first conduct an in-depth analysis of the tracking scenarios to gain insight into why a particular tracker's performance varies significantly in different scenarios. Referring to the performance of previous trackers on different datasets, we parsed out the tracking scenario attributes as follows: motion complexity, variation amplitude, target density, small target, and frame rate. We analyzed the datasets commonly used in MOT based on these attributes and find that these attributes vary drastically across different datasets. Both motion-dominated and appearance-dominated methods have their respective attributes which they do not excel at. To solve these, we propose a point-wise to instance-wise relation framework for MOT, which can generalize to diverse scenarios without manually balancing motion and appearance information. Specifically, Step 1. We use feature relation extractor to construct global dense relations with frame T for each point in frame T, 1 by a 4D correlation volume. Step 2. We transform the global relations into multi-scale point region relations and form a relation map for frame T, 1. Step 3. We perform hierarchical relational aggregation according to the point-part instance hierarchy to associate the tracklets and detections. To validate generalizability, we conduct experiments on 5 public benchmarks with significantly different characteristics: multi-class tracking in autonomous driving scenario BDD 100K, accompanied by low frame rates, large variations, and the presence of small target; ball game scenario sports MOT with complex motion patterns; dancing scenario. Dance track comes with serious motion complexity and large variation amplitude; pedestrian tracking scenarios, MOT-17 and MOT-20 with regular motion, high frame rate, along with higher target densities and the presence of a large number of small targets. We conduct ablation experiments on the BDD 100K validation set to evaluate our design of each component. Additionally, we take a further step to experiment and analyze whether our generaltrack can also perform well in domain generalization setting, which is a new and critical challenge in MOT field. Domain generalization in MOT is organized into 2 phases: detection and association. Here, we conduct domain generalization experiments for the association part, training only on the source domain and inference on the unseen target domain without fine-tuning. It can be noted that there is still excellent tracking performance on the 7 unseen classes and unseen datasets. Thanks for your attention.